Assalamu alaikum. I am Jahangir Alam, lecturer in physics. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class. And I am still okay and carrying on my regular activities. Dear students, I also hope all of you are well with your family members by the mercy of Almighty and carrying on your regular studies, staying at home. Dear student, in our today's class, we are going to discuss some important mathematical problem from the 8th chapter of physics second paper. That is the chapter of Introduction of Modern Physics. Right? And I hope this class will help you a lot for your exam. So dear student, let's start our class. Right. Dear student, first we need to see the necessary formula to solve the mathematical problem. Mainly today we are going to solve the mathematical problem related to time dilation and length contraction. And the necessary equations are T is equal to T naught divided by square root of 1 minus V square by C square. Here T is the duration of any event moving with respect to the observer, and T naught is the duration of any event with respect to rest observer, right? Similarly, the equation for the length contraction L is equal to L naught multiplied by square root of 1 minus V square by C square. Here L is the length of an object moving with respect to observer. Shortly we can see that moving length, and L naught is the length of an object with respect to rest observer, which is known as shortly as rest or rest length, right? In both expression we use V and C. Here V is the velocity of the observer or the velocity of the frame of reference, and C is the speed of light, right? Dear student, so let's see the mathematical problem. Dear student, here is our first mathematical problem, and according to the problem said that at what speed a hypothetical train should move so that its length becomes 1/3 of the stationary length. That is, at what speed a train need to move so that moving length will be 1/3 of the stationary length, right? Here if L and L naught are the moving length and stationary length of the train, then according to question the moving length, that is L will be 1/3 of the stationary length, right? So we know L is equal to L naught square root of 1 minus V square by C square. So we need to determine the speed of the train, that is speed of train V is equal to what? Or according to the question L is equal to 1/3 of L naught. So 1 by 3 L naught is equal to L naught multiplied by 1 minus V square by C square. Or omitting L naught from the both sides, we can write 1 by 3 is equal to square root of 1 minus V square by C square. Or squaring in both sides, 1 by 9 is equal to 1 minus V square by C square. Or rearranging this, we can write V square by C square is equal to 1 minus 1 by 9 or 8 by 9. Okay? Or V square is equal to 8 by 9 into C square, or V is equal to square root of 8 by 9 into C. Now using the value of C, we can write square root of 8 by 9 multiplied by C. You know the speed of light is 3 into 10 to the power 8. Okay, and after the calculation you will get 2.83 into 10 to the power 8, and the unit will be meter per second. So dear student, this is the required speed of the train at which when it will move, the moving length will be 1/3 of the rest length, right? Dear student, here is our second mathematical problem, and the problem said that the mean life of a meson particle is 3.0 into 10 to the power minus 9 second. If the particle moves at 0.9 c, that is 0.9 time of the speed of light, here c means the speed of light, then determine its mean life. Okay, so here 3.0 into 10 to the power 9 second, it means the rest mean life. Okay, here rest mean life T naught is equal to 3.0 into 10 to the power minus 9 second. Speed of the particle V is equal to 0.9 c. So we need to determine moving mean life. So T is equal to what? Okay, so we know T is equal to T naught divided by square root of 1 minus V square by C square, or T is equal to, you know, the value of T naught is 3.0 into 10 to the power minus 9 divided by square root of 1 minus V. Here the value of V is 0.9 c. 0.9 c divided by c square, right? So T is equal to 3.0 into 10 to the power minus 9 divided by 1 minus, after cancelling c from the both part, we can write 0.9 square. Okay, and after the calculation you will get 9.6 into 10 to the power minus 7 second, right? So dear student, this is the moving mean life of the particle. Dear students, now we are going to see an creative question, and the stem of the creative question said that an astronaut at the age of 25 years went for research by a spacecraft moving at 2.6 into 10 to the power 8 meter per second, right? He went for research work at the age of 25 years with a spacecraft which is moving at 2.6 into 10 to the power 8 meter per second. According to the calculation in Earth, he returned after 40 years. Length of the craft was 80 meters. That is, the rest length of the craft was 80 meters. And the questions are, first they said that determine the moving length of the craft. That is, 80 meter was the rest length when the spacecraft was on the Earth surface. Then the length was, length measured by the Earth observer was 80 meter. But we need to determine the moving length when it was in moving what is the length of the spacecraft, right? So here rest length, which is denoted by L naught is equal to 80 meter, right? Speed of craft V is equal to 2.6 into 10 to the power 8 meter per second. Speed of light C is equal to 3 into 10 to the power 8 meter per second. So we need to determine the moving length. L is equal to what? Okay, we know L is equal to L naught multiplied by square root of 1 minus V square by C square. Okay, so using the value L naught, you know the value of L naught is equal to 80 meter multiplied by square root of 1 minus V square. You know V square is equal to 2.6 into 10 to the power 8 square divided by 3 into 10 to the power 8 square. So after the calculation, dear student, you will get, it will be 39.9 meter. So this is the moving length of the spacecraft. Okay, I hope you got it. Okay, now we are going to see the last question. According to question D, whether the ages of the astronaut will be same or not according to himself and calculation in Earth, right? You know, according to time dilation, the time of traveling or duration of traveling will be different according to the Earth calculation, according to the astronaut, right? So first we need to determine the time travel calculated by the astronaut. That will be the actual age of the astronaut increase during the research work, and that will be 40 years according to the Earth calculation. So after the calculation of the ages increased by the astronaut during his research work or during the travel, then we will be able to calculate the actual age of the astronaut and age calculated by the Earth people. Then we can compare the whether the age will be equal or not, right? So dear student, here the time of travel according to Earth was 40 meter. Here traveling time calculated in Earth, right, which is denoted by T. T is equal to 40 years. Okay, speed of the astronaut V is equal to 2.6 into 10 to the power 8 meter per second, right? So traveling time calculated by astronaut T naught is equal to what? Okay. So dear student, you know the relation between T and T naught is, we know T is equal to T naught divided by square root of 1 minus V square by C square. So from this expression we need to determine the value of T naught. Okay. Or T naught is equal to T multiplied by square root of 1 minus V square by C square. You know the value of T, we have shown in the given information 40 years multiplied by square root of 1 minus V. V means 2.6 into 10 to the power 8 square divided by C 3 into 10 to the power 8 square. So dear student, after the calculation you will get almost 20 years. So 20 years is the traveling time calculated by the astronaut and 40 years is the traveling time calculated by the people on earth. Now so A is calculated by astronaut is denoted by T1 is equal to, he started his journey at the age of 25 years. So 25 plus, according to his calculation, his traveling time was 20 years. So 20 or 45 years. Similarly, A is calculated by in earth. T2 is equal to, he started journey at the age of 25 and according to the earth calculation the traveling time was 40 or 65 years, right? Here T1 and T2 are not equal. So we can say that the ages according to the astronaut and calculation in earth will not be same. So dear student, I hope you got it and I believe that you will be benefited from our 2 days class. So dear student, you need to practice this type of problem from your textbook for your better result or better realization. So thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.